everyone. Good afternoon. I hope I'm audible. My name is Dinesh Prakash, and in today's talk, I'm going to talk about how secret scanning tools like xGitGuard used in minimizing or preventing secret leaks through source code in version control systems like GitHub. So before going into the talk, let me give you a high-level intro about myself. I'm working as a senior manager in Comcast, and my team is called as Spider. We focus on research and development on privacy side. And I handle the product development side, and this is about myself. And now let me go on to the agenda for today's talk. So in this talk, I will be covering about the problem of secret leakage and its impact, and how the defensive techniques like xGitGuard helps in preventing those, and also the open source version of xGitGuard, and also I will touch upon other open source projects came out of Spider. Developers in general use code sharing platforms like to push their codes or to share their codes with their peers. During this process, sometimes they might end up in sharing the secrets into the GitHub version control systems. And this could be an opportunity for external threat actors where they could access this source code and extract these kind of secrets to breach into your applications. So this is becoming a worrying trend across many organizations. Like I could give a few such examples because why this has been trending. Like some of the attacks like SolarWinds or where they use this kind of secret leakage in GitHub to do a supply chain attack. Because like in this attack, the source is like came from insider threat. Basically, the employee from the SolarWinds like basically pushed secrets into the GitHub, which was used by an attacker to do the supply chain attack. And there are various such instances like transportation company where customer data was leaked, or there is a Mirai attack happened on IoT space. All these common spaces like due to this kind of source code leakage. So that's where organizations started to focus more on secret scanning capabilities, and we came up with this idea of xGitGuard in 2019. And let me go into like see. So as we know like now what is xGitGuard? It is about a prevention technique in identifying and blocking the secrets. It runs in two forms, one as a post-analysis scanner and other as a live scanner. So difference between this is like post-analysis something like already the secrets has been published into the legacy codes, and the live scanner or something like while we are doing our development, we might push something and it would block you from pushing those. And the purpose of having this post-analysis scanner is not just scanning over the legacy code, but also like you can't enforce your individual who wants to push something into the public GitHub. So that's why we are using these legacy code scanners. And the importance of having this kind of secret scan capability is not just safeguarding your organization's security posture, but also induce trust into the developers that they can do this kind of code sharing without thinking too much about whether their secrets have been leaked or not. And let's see how xGitGuard works. So xGitGuard works on three operating principles, like one is searching at GitHub or like any version control systems, and detection of secrets and the remediation phase. These are the three core principles of xGitGuard. Before let's seeing how xGitGuard works, let's see what are secrets. Secrets are categorized into two. One as credentials and other as tokens or keys. Many wonder like what is the difference? Secret is a secret, right? So credentials are something like a plain text passwords, which could be used in your database, or it could be a database passwords, account credentials, which doesn't have any specific patterns. And tokens or keys are something like secrets with specific patterns. This could be like SSH private keys or any API keys, like you could take AWS key as one such example. So most of the tools available in markets like earlier was lagging in identifying these kind of plain text passwords. So that's where we came up with the coverage for both, which makes this as a powerful tool. Apart from this coverage, we have a few other advantages. We did research over the other tools available in market and came up with like overcoming some of the limitations there. So here, this product is just not relying on like regex or entropy. It has a core machine learning model. It is not like LLM based or something. We have our own core machine learning model where we train based on the GitHub data sets and trained our model for doing the context-based analysis. And the coverage itself, which we've seen, where we are providing coverage for both credentials and the common keys. And the scalability factor, we have a query engine which is able to provide coverage for entire GitHub repos. Like it doesn't matters like how many repos or volume of data you are feeding. And the usability, here you doesn't need to do anything on like onboarding stuff, like it is an automated onboarding either for live scanner or a post-analysis scanner. And it doesn't have any development overhead because it's not going to run on your individual machines, it's going to be running on something on a cloud server. So let me go into the actual workflow of how it works. So xGitGuard starts at searching for GitHub. So for doing this search, we have a query engine for which input is based out of different parameters. And this query engine would be identifying the potential document which could be containing some secrets. And this would be fed into the next set of process of pre-processing. And once it is done, after we removing all the relevant noises, then we would do a secret extractions and model validation. And xGitGuard then would identify the developers who is responsible or team is responsible, and then would feed into the next set of process because ML is not a 100% always accurate. So there is a need for a developer to do the validation over those secrets, whether it is an actual true positive or a false positive. And in case of it is a true positive, then we would send for the next set of process of remediation. And each organization has a different kinds of remediation process, but in general, the recommended thing is not just removing the code line which contains secret from your code is not enough. Like we need to remove the entire data sets from the commit history. There are certain recommended tools like BFG, which we could use to do that. And the query engine itself, what I'm talking about, how the coverage, like how we are able to identify this kind of plain text. So we have this query engine for both the credential and tokens or keys. In case of the credentials, it starts with the search. To do the search, it classified into three, like a primary keyword, secondary keywords, and extensions. So these primary keywords are something like used to identify whether the searched file is relevant to your use case or not, or your enterprise or not. And the secondary keywords are like assignment variables, like where your line of code which contains secret is located, and the extension is the support, like where in our case we are providing like over 48 plus extension supports. And this combination would be fed into the query engine, and the query engine would create like a multiple combination and permutation of searches and pass into the worker nodes. And the worker nodes would be searching the GitHub for like to identify all the potential candidate files. The potential candidate in the sense the file which could contain a secret. And before processing to the next phase of processing, doing the actual secret extraction, we have a concept of hash table validation. This is for optimization and deduplication. We doesn't want to do the search over same file or document again and again, and we want to get rid of duplicate records in our inventory. So as soon as this validation done, then it would be fed into the next phase of text processing, where we would do all the data cleansing and noise removal, and then the secret extraction would happen, where we would extract all the lines of codes which could contain a secret. And it doesn't stop there. After extracting these lines of code, we have the model which does the context-based prediction, and that's where the validation phase would happen. And the tokens or keys as the similar process. The only difference you guys would see here is the search keywords and the text processing. As I mentioned, the tokens or keys are with any specific patterns. So we here doesn't need to have this assignment variable in place to identify the code of line. Instead, we use the regex, compile list of regex patterns to extract the line of code which could contain secret. And then again, the same process, we would feed that into the model for prediction. One thing I want to mention is these primary keywords is specifically for legacy scanners that to search on public. But for enterprise deployment, it doesn't require, because we already know the context that the code base, whatever we are searching, is relevant to your organization or whatever use case. So some of the core capabilities of xGitGuard is like the model itself. So this model was trained with, like as mentioned, like core machine learning model, where you train with the local data sets of GitHubs, and it has the accuracy rate over 90% each. And additional to that, the query engine, which I was mentioning about, it's not just about the coverage, also the scalability. It is scalable to entire GitHub repos. And the other factors are like other core capabilities are like doing a context-based search and targeted search So basically, this is used for instant team. Assume that you have some certain of leaks which you found in bug bounty, but you want to find that whether such kind of leaks are available in any other instances or not. So the instant teams could use these kind of capabilities to do the search over other areas. So let me also talk about the open source version of xGitGuard, and this was released for the open source community from Comcast. So this open source version is released as a framework in two forms. One to run with model and other to run without ML model. And the model itself here we didn't release as a pre-trained model. It would be like a user. It could be a team or organization or individual user. They can run on there independently to do all the data collections, data cleansing, labeling, feature engineering, and creation of their own model respective to their use case. And the other end, why we released without ML model is if you are an individual contributor or user who wants to use this framework, you might not have a source to create your own model, because to create the machine learning models, you need a lot of data source needs to be collected and trained. So this particular framework without ML model provides the coverage, but the only con there is since we don't have a ML to validate, the accuracy rate might not be as high as what we are looking with ML prediction. So let me share the link of the repo. So I will leave it for some time so you guys can scan it over to look into the open source version of xGitGuard. And if there are any feedbacks or queries or collaboration, please reach out to us. So I will keep this for some time. So I will move on to the next. As we are having doing more internal features and releasing to our internal versions, we also want to slowly release that for open source community. So this is our roadmap for our open source version. So to start with, we have a plan to release this ad hoc scan to do the targeted scan and context-based scans. So this is specifically for team who wants to do this kind of incident analysis. And then there is a file scanner capability. So this is a standalone framework. It is not associated to any version control system or services. So this file scanner is basically you could integrate with any of your services. We have done few. And it is a platform agnostic framework, and it also could be used by anyone who wants to scan over their local document or files in the local machines. To do this kind of secret scan. And then the model, again, this won't be a pre-trained model. It would be this is a transformer model we are using. So this would be again kind of a framework where you could do your own training and creation or building of your model based on your use case. And the last, we have a pre-commit hook. So this is what the live scanner I'm talking about. We deployed a server-based hook for our internal purpose. So basically how it works is whenever you do a git push, it would scan on your GitHub server for any sensitive information and block you from pushing that. But this pre-commit hook is something like a client-based hook. So we can't, this is an open source, we can't enforce this kind of automated deployment. So this client-based hook can be configurable by whoever the individuals wants to use this product. And they can, whenever they do a git commit, it would scan over those commit ranges and look for any potential secrets and block you from pushing. Apart from that, there is a plan to extend this open source version to other platforms like version controls like GitLab or Bitbucket, and also extending the services to other apart from version control, there are also a recent trend of secret leakages happening via containers like Docker. We could take one example. So this is on xGitGuard roadmap, and now I also like to talk about few other open source projects from Spiro. So our team is not just a product development team. We used to do a lot of research publications or patent filing and open source work. So these are some of our open source works. So one we have seen is on xGitGuard, which is about finding secrets, and then the xCompass. This is used in PDL, privacy development lifecycle, to do a privacy requirement analysis. and this has been incorporated to a NIST framework. So during your privacy threat modeling, this could be used to assess your architecture diagram against your privacy requirement and find any privacy relevant gaps. So we released an initial version. This is in the initial stage. And then the guardrail, this is project guardrail on AI. This is a AI safety tool. This one is specifically designed to do a risk score assessment over your AI solutions. And again, it's still in initial stages. So I will share the links for this. So we have the links for Project Guardrail and XCompass. So scan over that, and also our team page. Basically, what are the works are going on in our space. So I will keep this for some time. So as I mentioned, if anyone interested to know more about this work or collaborate, so we are actively also seeking for maintainers for these open source projects. Please contact us. These are our contact IDs. So we are very open to collaboration, and we want to evolve this project. So that's the end of my talk. And today's talk, we have seen like the importance of having a defensive techniques for secret leakage, and how xGitGuard helps, and the open source work of that. Even though we have the defensive techniques like xGitGuard to do this kind of secret scanning capability, I would always recommend to have a best secure development practice. Because like, while we are developing itself, if we use like some kind of a secret management services, whatever your organization is recommending, so it's always good to have that kind of practice before hard coding any secrets into the version control systems. So that's all about my talk, and thanks for giving me this opportunity in BlueHat and this forum, and thank you all again. Bye.